BGP today. Unlike the people before me, I don't have a root server and I don't have it init specifically. What I did as a need is I wanted to use BGP to announce prefix from my host. And that's how I came to look into BGP. So different approaches and different issues. So the application I created works, and that's how I came to understand BGP in details, and allows me to replace, obviously, some applications which are much more complex, as a root injector doesn't need all the logic of all the RFCs. So when we speak about BGP, what are we speaking of really? There is plenty of RFCs and plenty of documents which are very interesting if you cannot sleep or plenty of time. The main one is 4271, which define all the main protocol. 5492, which is really linked to this one as well. Both are interreferenced, which is the one which allows really to add functionality to BGP and make it evolve with time. RFC 2385, which is a MD5 signature, which I cannot do as my language of development doesn't support it. I cannot do TCP with MD5 with it. Other RFC you may have known or used when you configure router, which is 3107 for MPLS, 4660 for multi-protocol extensions, that will be for IPv6, for example. And the last one is 4893, which is the 4-octet support now on ISN. Some you may not have heard of or you may be using without knowing is 4724, which is Western Start, which is something you will use if you have redundant routers with main and backup routing engines. 4360, which is extended community attribute, which allows to pass bigger communities. And 5575, a new RFC from August, which allows to pass flows being really some policies using BGP. Those RFC are interesting as they allow on the host level to do different things than what they were intended for. So I will speak about BGP, I will speak about how it works on the wire, not how you see the problems. I will say that even if we heard people today complain about how bad the implementations are, I must say that I found them quite good. I had to write mine, and I think that finally, if I could do as well as those guys, I would be happy. So when you look on the wire, BGP is more or less a mixture of packets, like every protocol. Every packet has a type, so you can have an open, which is what a BGP router will send to negotiate a connection. Notification, which is used to tear down connections and say that, oh, something went wrong, go away. Keep alive, which is used to make sure that your peer is still there, asking for the heartbeats. And update, which is a packet which is sending the route information between routers. So when you have when you have a BGP session, you have a number of states. You may have seen when you configure your router, it goes from idle to active. Stuck in active is a known expression. What happens is you will have a packet sent by a router. The router will expect an open packet will be sent by a router, which will expect both an open packet in return, then a keep alive, and at the end will send himself another keep alive to close the handshake. It's very similar to a TCP handshake. After those initial, I will say, handshake, you have an exchange of routes for your updates. So every router teaches the other one what he knows. And from that moment onward, both routers will exchange keep alive packets to make sure the connection stays up. BGP clearly states that they will not rely on TCP for detecting the failure of the other peer, but will actively send keep alive to each other. So what the message does look like? Every message has a header, which is the same for all of them. For legacy reasons, it starts with a very long 16 bytes of ones, which come back from the old days of BGP 3 and 2 and perhaps even before, where there was a smaller header, described here, which described the BGP packet for that previous format, and which had been blanked, so compatibility could be kept and the port could be reused. So every message has a number, so open is 1, update 2, and those are stored in the message header, which allows the router to process the packet accordingly. So open is the first one. The formatting has been lost, so sorry. The version, now. So the version is 1 byte, which is BGP4. You have the ASN of the sender, the hold time, and an identifier. The hold time is the time which will be used to calculate the interval between two keep alive messages to make sure your peer stays alive. Identifier is a 4-byte unique number, but is often represented as an IP address. So the hold time is not the same by vendor. There is no real standard, and each vendor may have a different default for his hold time. Juniper is 90, Cisco 180 seconds. What is important is that both routers will negotiate the smaller number. So should you want, for example, have a BGP and a root injector, in my case, on a server, announcing some service IP to your core, you can force a very low hold time to your router, forcing it to exchange with you a lot of hello packets. The RFC clearly states that it cannot be lower than 3, as you must not send keep-alive packets more than once a second, and there is some explication. So a minimum hold time would be 3. However, which is interesting is that even if I never saw the behavior, it says that you can reject a connection based on hold time. The hold time, a router could say, that's too low, I'm too busy, I have too much CPU resources, I will start to refuse connection which have hold time which are too low. The BGP identifier is to open an IP address. Everyone is used to see it an IP address, but it's not an IP address. So even if you think of it about as an IP, this integer is often defaulted to the IP where the connection comes from. So it's very, very practical to have it expressed as an IP even if it's not. So in the open packet, you have capabilities, which is the extra bit of information at the end of the packet of the open, which allows you to define new behavior for the software and toggle on and off some options. You have a code, a length, and a value. It's very simple, so it's a kind of BGP tend to have always the same kind of structure where it tend to prefix all the data with a size for easy parsing. And capacities can be sent multiple times. So you can have a capacity will mean something, send multiple times with different values. For example, one of them you use is a multi-protocol extension, which is used to exchange non-IPv4 routes. You can say, using the same type of information, I will take IPv4, IPv6, I will accept, and others kind of family packets. So what you have is, mainly for multi-protocol MPLS, the important part is which family of packet you will accept, which are defined on this page. The only important one for this talk are IPv4 and IPv6, and for the family unicast, multicast, and MPLS. So multi-protocol extension is a way that BGP use to extend the protocol to just not be limited to IPv4 IPs, but to do more than that. Graceful restart, which is another capability which can be in the open message, is used to let your other speaker know if you have died. I will start slightly. When you enable graceful restart, you are enabling your peer, the peer router let his peer know that he is able to stop functioning and still route packets. Which means that should you have a router which have an hardware ASIC and can, for example, fail as the main, we say, blade with the routing engine fail, should your router have a second blade able to do the same job and fail over smoothly without stopping routing packet in the middle as the ASIC is still doing the job, graceful restart let your speaker know he can do that. I will pass the packet as those have been changed in formatting. So it's a dump of Cisco open packets, which means that you can see the parsing done by Cisco when you turn debugging on. Notification are the second type of message sent by BGP. They are just used to indicate to your peers that a fault has occurred. The router didn't like the packet format, something was corrupted. Simply something went wrong on the forwarding and you want to tear the station down, then a notification message will send. There is six types of notification. which depend on the type of message you have received before and what information you want to communicate. The normal one are message header errors. So if you have corruption of a packet, it will be there. Open, if you are refusing open message as you don't support something or your router cannot understand the open packet we came to it. Update, inform that an update was malformed, you send a route, impossible route or something. All time expired means that your router didn't answer in time to keep a live packet, so you can have, before closing, you are going to send an all time expired. State machine errors are for processing of all the message. When the processing and the state machine of the BGP, the routers is in very state, you're going to notify your peer, and C, stage analysis. Keep alive is the smallest packet from BGP, just the headers, and it's just used to notify your peer that you're still alive. When you came to an update packet, the update packet of BGP is very, very nice. At least when you stay in the IP forward. First, you are going to find a section which gives you the route to remove, a section which defines the characteristics of the routes, which are all the path attribute, origin, all the things which are defining the routes, and all the new routes on which you should apply those attributes. So the routes are defined in a format which is the NLRI, Network Layer Attribute Information, which is a way to anchor the prefix, removing the empty space when not needed. So the path attribute is a part of where most of the information and most of the complexity of the BGP protocol reside. It's where you will set the IS path, the origin, your MED, your local pref, all those things we define the routes and which will configure your router to perform one action or one other. Your information can be transitive, which means that, like you expect for your IS path must be passed from one router to the other. It can be optional. For example, some of the value don't have to be there. You are not obliged to set up a local preference on a link or a MED. Mandatory, those are things which you must always have in a packet. Partial is a way to let you know that you have received a packet which have an attribute. You don't know what it does. You just are passing it through without touching it, as you don't know what it was. Some attributes are entered in two main categories, which are mandatory and discretionary, which are the main attributes that all implementation of BGP should implement, must implement. Once again, it's hard to read, but those are this is a table which defines which kind of attribute have which characteristic. The origin, which is where the route came from BGP or IGP or any other source. The IS path, which is which other AS saw it. The next hop, which is where to send the route. Your MED, your local pref, and other things like communities, which you can use to control the behavior. The path attribute itself, each path attribute, so each of those capacities, each of those features, like origin, IS path, are stored in that path attribute. And you can see that some flags are set to depending on which of the value it should have. Router will refuse packets which by RFC are told to be, for example, optional. If your packet is not optional, your router is in its right to refuse the connection and close the connection. I will very quickly skip over all the kind of attributes you can have. The origin, the IS path, which can be of two types, which is an IS set, which is used for aggregation, and the IS sequence that you know most likely is that what you are used to see when you look at IS path. The next hop, which you can see is only a 4-byte value, so I have no way to carry in any way, shape, or form an IPv6 route. And your local pref, MEDs, and others. So some things there again. You can ask your Cisco router or any router to dump you what an update look like if you want to know exactly what is inside and why the router came to the conclusion it came to. So when you get an IPv4 running BGP implementation, you may want to add IPv6, which is why I looked into doing mine. I wanted to use software which was I could integrate in my code base and needed IPv6, and I couldn't find any. So to announce an IPv6 route, the way BGP decided to do is to create a new attribute, which instead of being a definition of an attribute of a route, would be the route itself. So the nice, I will say, encapsulation which was in BGP up to now, where things were all encapsulated and all inclusive, stop, and suddenly you're starting to use path attribute for not only information about routes, but for routes themselves. So the things that routes get stored in is called a multi-protocol unreachable NLRI when you want to remove the routes, which is a path attribute we define the family of the route you want to announce, and the you want to remove, and the route you want to remove. So in that case, it will be the IPv6 route you are expecting to you want remove from your peer. The multi-protocol reachable packet contain both a route and its next hop. So when before you had the next hop in attribute, they didn't create a new attribute for a new next hop. They decided to instead put everything in one big packet. So I would like to stop a little bit more on Graceful Restart, and which is an interesting feature when you use BGP not for routing but for announcing prefix. Graceful Restart was created to allow non-stop forwarding in case of failure of hardware when there's a code, but it can be, I would say, perverted to be used to announce routes from servers, which allow to make sure that even if you reboot, oh sorry. Yes, I already said that. So what happened is, what is this packet is there is a number of information passed through. One is a restart flag, which you indicate that when you're coming back from failure, a router will let you know his peer if it's a normal starting of the routing engine, or if he comes back from a failure and is recovering the route. And for doing so, the router will let know how long his peer should wait for the Graceful Restart feature is there to allow route to stay on when the router reboots. And in order to do so, the speaker will announce how long he expects to be down first. He will expect to be down for a few seconds, and should the router be down longer than that time, obviously the route mustn't stay forever in the routing table. So the restart time allows a router to know how long to wait for a peer during a reboot. And the restart flag allows to know if the reboot is completed or not. So the route is marked stale, which means that it's still valid and still used for routing, but no peer and no one is announcing it anymore. So sorry. FlowSpec is another part of BGP, which is interesting. It's a use of BGP not for sending any more routes, but for sending flow information. Flow information is like a firewall policy. Instead of sending, I would say, configuring firewall yourself, you can get your router to accept a flow which will define a behavior of the forwarding platform from that packet. So a flow is a new kind of NLRI, which is exactly like an IPv6 packet or an IPv6 information or an MPLS. It is stored in a multi-protocol using the multi-protocol feature. It's allow you to define quite precise filtering routes, like you will use on a normal firewall, which is using your prefix, your source and destination prefix, your protocol, your port, your SNMP type, and use extended attributes to perform actions. Those actions are defined by the RFC, but a lot of things must be configured on the router themselves to make it work. So the RFCs themselves are quite clear, I would say, except the flow the flow spec RFC. They are quite clear. The packet, the router and implementation vary between vendors, and they all don't always behave. So when writing an implementation, you may find that what works with one vendor doesn't work with another. Some vendors, for example, like Juniper, have much more stricter control and validation of the packet than for example, Quagga. There is difference between the implementation and the vendors. But nothing which would cause issues when you are trying to do things. It's a pretty straightforward things. One thing which is interesting is when you are looking at Cisco, it seems that Cisco use its specific Cisco route refresh to change the way it will behave on negotiating the start sequence of packets. You will expect an open, an answer, a keep alive, and then I would say an exchange of routes. So the 4 packets making the uncheck, then an exchange of routes. What you found that when 2 Cisco routers start to speak together, they will often, if you have no route to exchange, send 2 keep alive in a row, which means the first keep alive is not really used as a keep alive. It is used as a replacement to say there was no route. And then the second one is sent to say, oh, yep, there was no route, and now he's a keep alive, which is allowing to the conversion to go faster and not to wait for the first keep alive to come back after the timeout of the old time you have, and allow to save the old time, to save on routing conversions time. Something I skipped before is the multi-protocol extension define a new way to converge, a way to accelerate routing conversion, creating what is called an end of record packet, which is an empty route with nothing inside it. So what happens is when you are sending your route, you send all your routes, send that end of record packet, which is an empty route, and you want to say, oh, there's no more route now, so I can start the conversion process. I can start to update the RIB and to forward things differently. The way I use BGP and why we done it is to create a route injector. So it was initially to be able to announce ASN 112 in our network. So it's announced currently on network all our services. So all our /32s and 128 are announced to it. Restful restart is used, as I said, in different manners. Instead of using it for having resilience in case of failure, we allow it. We use it so when we reboot a router, obviously the BGP will go down, the router will reboot and come back. In a normal case, you will expect the route to drop from your network and come back. So you should not, even if your machine comes back on the fly, if you try to ping it, until the process starts, there is no route to it. Having restful restart means that you can reboot a machine which is announced via BGP. It comes back, and as soon as the IP address is brought back, you have an X up, and you can then access the machine. Be able to change the whole time allow to a very fast failover. So if your machine becomes very busy or very slow, it's possible to just detect it very quickly and fail back to another one using BGP. You have 2 machines, one using MED or local pref, a master one, a backup one. If your main machine is working fine, it's taking the connection, your machine goes down, the BGP session goes down, and then automatically your core will start to route the traffic to your backup machine. One of the reasons as well using BGP is interesting to announce routes and compare to other protocol and other way is that some hardware do not like gratuitous ARP. Some way to have service IP address is to have an IP address on a machine, and should the machine have an issue, another machine will notice it and say, oh, the primary service is down, I should take over the personality of the machine, send an ARP packet saying, please give me I am in charge of that IP now, send me the traffic. Some router like Juniper by default don't allow it, as it will allow, for example, your customers to spoof each other's IP address or try to intercept traffic which is not allowed. So as a security precaution, it's turned off. And cannot be turned on a per VLAN. So should you use VLAN and trunking, you cannot, for example, enable it only on hosts and not only on customers, on DSL or other things. You are bound to the interface. So using BGP allowed to go around this. So the application I wrote very quickly, take a Juniper-like configuration. It's a very, very simple configuration like you expect from everything. You have a neighbor statement, which is not visible on the slide, the top, with the IP address, the description, the router ID. All the parameters you can set up, I briefly spoke of, which I set up before, like the hold time and the graceful restart. If you put no values, obviously, the default will be used. And you can define routes exactly like on Juniper. So the program has no dependencies, so we can work without any. It can be installed on a Linux box. It will work on what is installed on a blank install. It's in Python, single-threaded, so there is no thread. So obviously, it's not done for very high load programming. It's just do for announcing a few routes from a few machines. And do you have any questions?
Hello, Thomas. Bradley Freeman from Janet. A couple of questions, even though you only mentioned it briefly, regarding the flow-based routing. What's the vendor support like for flow-based routing at the moment?
I know that Juniper supports it, as obviously they wrote the RFC with Arbor and NTT. I don't believe there is support on Cisco now, but I don't have any Cisco equipment, so I cannot guarantee. And that's all I know about it.
And would there be any extra impact on the routers that are running this?
It really depends on your hardware. If you have an hardware where you can pass those, on some hardware you can define policies and routing which are not only on packet but as well on some option like a firewall. If your ASICs allow it in hardware, it should really go at hardware I would say without impact. If you have to go through the from URI and it must be then software switch, then effectively it will have a bigger impact. So it will really depend on the platform you are running it on.
Okay, thank you.
Any other questions for Thomas? Okay, thank you, Thomas. Okay, so